Okay, we're going to review some of the basic concepts that you've learned so far in Chapter 8. We'll start with prime factorization of numbers. There's a few ways to do this. I'm going to start with obvious numbers that I can um, divide by. So if I can take an even number like this, 128, I can cut it in half. So 2 is a factor, leaving 64. I can cut that half again, 32, again, and again. And we keep going until we get all of these 2's. So the prime factorization is going to be 2 to the 1, 2, 3, 4, 5, 6, 7. 2 to the 7. 125 in the same way. We can factor that into a 5 and a 25, and then 25 is 5 times 5. That gives us 5 to the third. We don't need to have every factor be the same number. That was just a coincidence here. All right. Moving on. Find the GCF, or greatest common factor, for each pair of monomials, in this case 30 and 75. The way I like to do this is to try to find the biggest number that can go in. I see that 3 and 10 work, and then 3 and 25. 10 can factor into a 2 and a 5, and 25 is a 5 and a 5. So we have one of the 3's, or the 3's, and then a 5 and a 5, giving us 15 times 2 and 15 times 5. That makes the greatest common factor 15. That's the biggest number that goes into both of those terms. Look over here at question 4. We see a 24 and a 32. We're going to want to factor that. I'm going to go ahead and factor a 2. I see what I believe it's going to be, but we'll do it slowly here. 2 and a 12, 2 and a 6, 2 and a 3. And then a 32 has a 2 and a 16. And then quite a few more 2's here. And so our greatest common factor is going to be 2 to the third, which is 8. 8 is the greatest common factor of the leading coefficients. Then we have an 8 to the 11 and an 8 to the 2. 8 to the 11 is like 8 to the 2 times 8 to the 9, so we can factor out an a squared, and that gives us, for a monomial, 8a squared. And since there is no b term in this second term, we don't get to put any more values in there. All right. And now we're going to factor each polynomial by factoring out the greatest common factor, the common monomial, and then we'll distribute it back in to make sure that it's correct. We see that each of these terms, the 9, the 18, and the 12, have a 3 in common. They don't have a 9. 9 goes into 9 and 18, but not into 12, so just a 3, and they all have an f to the 1. So that leaves 3f times what is 9f, that's just a 3. 3f times what is 18f to the 5th, that'll be a 6f to the 4th. And then finally 3 goes into 12, 4 with just one f. And we're real close to being able to factor more than just the 3f out, but 3, 6, and 4 don't have a common factor. And if we did distribute this back in, we'd see that 3f times 3 is 9f. 3f times 6f to the 4th is 18f to the 5th. And then 3f times 4f is 12f squared. All right. Clean that guy up a bit. Why don't you try number 6 here? See how it goes. Hit pause. All right. We see that 12, 36, and 24, you can break it down into 2's and keep factoring out. I see that 12 is going to go into all of them. And then they don't share a variable, so all I can get is a 12 out. That's going to leave a negative a squared plus 3b to the fifth minus 2c to the third. And if we distribute back in, 12 times negative a squared is negative 12a squared. 12 times 3, that's 36. B to the fifth. And then lastly, 12 times negative 2 minus 24, c to the third. So it checks, but our answer is actually, for these, our answer is going to be this this set of terms in black. I'll do the first one. I'll ask you to do the next one. We see that there's a common binomial here, a plus 3. If we factor that out, a plus 3 in parentheses, that's going to leave behind a 3 plus 4a, 3 plus 4a. Why don't you try this number 8? Hit pause. Okay. You'll notice that again we have a common binomial, the 2r minus 1. We can pull that out. And that leaves behind 5 minus s. I suggest you don't use the letter s, especially when a 5 is involved as a variable, because it gets kind of messy. There's our factored expression. Now this one we're going to take a few steps here. They're written over on the right. We'll start with factoring each expression by grouping. The first step is to just group the first two terms and the last two terms and factor out the greatest common factor. So an 18 and a 6 share a 6. The r to the third and r, the highest degree we can put is in this r. That leaves us with a 3r squared minus 1. Remember that 1 there is kind of a placeholder. Bring down the plus. 30r squared and 10, factor out a 10, leaving 3r squared minus 1. And if you look, we have a common binomial, 3r squared minus 1 to factor out. Put that in parentheses, leaving behind a 6r plus 10. Now we could do more factoring if we wanted to, but we're just going to leave it in factored form with these two binomials. We could FOIL this to check our answer. 3r squared times 6r is going to be 18r to the third. A 3r squared times 10 is going to be a plus 30r squared. That term is sitting here. It's the third term. Then a minus 1 times 6r, that's a minus 6r. That's the second term we see above. And then, of course, negative 1 times positive 10 is minus 10. So it checks out. Why don't you do this next one? Hit pause, and then you can check your answer. All right. First step is to group the like terms. We have a 2m and a 3m items here. We can only factor out an m squared, leaving 2m minus 3. Bring down the plus. Then we have an 8m and a 12. They both have a 4 in common, leaving 2m minus 3. Now we move on to finding a GCF. We have a 2m minus 3. That's a binomial, kind of different than just a monomial that we could factor out, but we factor that out and that leaves m squared plus 4. That's our answer. We can check our work by FOILing. When I do first times first, I'm going to get 2m to the third. That checks. I'm going to have a 2m times 4. That's a plus 8m. That term there. If I do minus 3 times m squared, I get a minus 3m squared. And then finally, negative 3 times positive 4 is minus 12. All right, so the answer checks. This is my answer. Moving on. We're going to factor trinomials now into two binomials. As a quick reminder, you can read through this. When the constant term is positive, we've either multiplied two positive numbers and they'll add up to make b positive, or we've multiplied two negatives that make c positive, but when you add together, the b would be negative. Likewise, notice over here when c is negative, so this, I could have written this as minus c. When c is negative, it comes from multiplying a positive times a negative. The bigger value is going to have the value for b, whether it's positive or negative. So if of the two factors that multiply to c, if the bigger number is positive, when you add together, b would be positive. If you multiply a positive and negative and the bigger number is negative, then when you add them together, the bigger number would be negative, and this b would be negative, or you'd have an x squared minus bx, and then the minus c. All right, put it into practice. We're going to find the factors of 8 that add up to 6. Hopefully, you see it as a 2 and a 4. We can then write this. We can do a factor by grouping if we want. Rewrite 6x as 2x plus 4x, or we can jump right to x plus 2, x plus 4. And if you FOIL that out, you should get the answer we started with. Why don't you try number 12, see how it goes. Remember, you have a negative. When you multiply to get a negative, one must be positive, one must be negative of the factors. We want to add up to negative 7. Okay, factors of 30, you've got a 130, 215, 310, 4, 5, 6, and 5, and that's it. Or 5 and 6. When one's positive, one's negative, we're basically looking for a difference that adds up to 7, or in this case, negative 7. So the bigger number is going to be negative. And which of these two factors adds up to a difference of 3, which of these two add up to a difference of 7, or in this case, negative 7? The 3 and the negative 10, giving us x plus 3, x minus 10. If you FOIL that out, it should end up the same. Try 13, similar problem. You have a negative for the end term, but it's positive, so the bigger number should be positive. The factors of negative 21, they're fairly easy. There's only two options, 1 and 21 or 3 and 7. 3 and 7 have a difference of 4. We want the smaller number to be negative, giving us x minus 3, x plus 7. FOIL it out, you'll see it works. Try this one, factors of 64 that add up to 16. Hit pause. Okay. You'll notice here we have a perfect square. The number 8 times 8 is 64. 8 plus 8 is 16. That gives us x plus 8 times x plus 8, or x plus 8 squared. That's called a perfect square trinomial. Number 15, it's hard to see it, but you have a 0c in the middle. So our middle term has to add up to 0. That means you have to have equal and opposite factors of 25, which obviously are 5 and negative 5. They add up to 0. We call this the difference of squares. C plus 5, C minus 5. When you multiply the outer and inner terms, you get a plus 5c and a minus 5c. That adds up to 0c, and therefore we don't see it. But you have a minus 5 times positive 5 and the c squared. This one's a little bit trickier. Basically, the quickest way to do this is notice you have a difference of squares because you're missing a linear term, a middle term. And all you have to do is look at the square roots of these two terms. And we're going to have 5x plus 4, 5x minus 4. And if you FOIL it out, you'll see that it works. All right, these are a little bit tougher. This is where we're going to find the factors in the middle, factor by grouping. Some kids are good at guessing and checking, but for now we're going to make sure that we know how to get the factors and rewrite the middle term. So 2 times 15, that's 30. I want to list all the factors that add up to 13. It's pretty obvious to me that 3 and 10 is going to work, so I'll just rewrite the middle term as 2x squared. The middle term then is 3x plus 10x plus 15. 3x plus 10x, if you add those together, you get back to where we started from. Now we factor by grouping. All I can pull out is an x, leaving 2x plus 3. Bring down the plus. Factor out a 5 from the 10 and the 15. There is no x in the second term. That leaves us with 2x plus 3. It's not a coincidence that 2x plus 3 can be pulled out, and what's left is x plus 5. If we FOIL this out, we'll see that we get the same trinomial as given above. Why don't you do this one a similar way? Multiply a times c, that adds up to b, the middle term, and then do the factor by grouping. Hit pause. Okay, 3 times 2 is 6. Factors of 6 that add up to 5 are going to be a 2 and a 3. So I'm going to write 3x squared plus 3x plus 2x. It wouldn't matter if I put 2x plus 3x. In some ways this one's easier. I can pull out a 3x, leaving x plus 1. Bring down the plus. Factor out a 2, leaving x plus 1. Looks like I have an x plus 1 for a common binomial, leaving 3x plus 2. And if you FOIL that out, you get our trinomial. And now we'll end with 2 multiple choice problems. Of course, you could avoid factoring by just FOILing all the answers, but that'd be 4 problems to do. If we learn how to do the skill that you're going to be tested on, we can do this faster. We want to find the factors of 36 that add up to 15. If you list all the possibilities, you can start with 1 and 36, 2 and 18, and then you get to 3 and 12, and you realize those add to 15. So I can rewrite this as x plus 3 times x plus 12. The answer is C. For 18, similar way, the factors of 16 that add up to negative 8. When we get done, we see that negative 4 times negative 4 multiply a positive 16 and add up to negative 8. And the question says, are we going to get a perfect square trinomial, or is this a perfect square trinomial? Can it factor into a single binomial square? And the answer is yes. X minus 4 times x minus 4 can be written as x minus 4 squared. Thanks, and hopefully you have some questions you can get answered in class and do great on the test.